Assalamualaikum, my name is Zafrie Haziq bin Zainudin. My matrix number is AD160053. I'm from section 1 of class DFMA. So we, DFMA student, given an assignment to make a video about the topic that has been given to us individually. So the topic for my video today is DFMA for machining. First, I will talk about what is DFMA, and the second, I will talk about DFMA for machining. DFMA stands for Design for Manufacture and Assemble. DFMA is a combination of two methodologies, which are Design for Manufacture and Design for Assemble. Design for Manufacture, which means the design for ease of manufacture of the parts that will form a product, and Design for Assembly, which means the design of the product for ease of assembly. By simplifying the design of a product, it is possible to manufacture and assemble it more efficiently, in the minimum time and at a lower cost. There are some facts about DFMA, which is the first DFMA software was developed in 1983. DFMA software can identify the cost reduction opportunities in the product structure and can calculate should cost for a new or existing piece part design. So this function acts as very important tool in the industry at that time. There is one big company reported saving billions of dollars through the DFMA software. After the report were spread out, the DFMA software has been used by most of the industry and become standard. What is DFMA? DFMA is a methodology for optimizing a new concept for an existing design with respect to manufacture and assembly by reducing the number of components or process needed by eliminating excess component. We also eliminate the drawing of this component, the need to keep up to date, the risk of wrong production of components, the need to store them, and the risk of incorrect assembly of the product. The DFMA consists of 4 steps, which is the first one is conceptualization, analysis, redesign, and conclusion. To understand to each of these steps, we are going to apply the DFMA process to the T set, which consists of teacup, salsa, and spoon. In the conceptualization step, we can review the user requirement of the product. In this case, we choose T set. So, the product must be able to hold hot liquid, possible to pick up one hand without getting burned, place it to flat surface when needed, stir the liquid, and affordable and attractive to the market. During analysis, we assemble the product pass by pass on paper to build the assembly diagram. Assembly diagram consists of components, processes, combined component, main assembly, and sub-assembly. The goal of analysis to uncover at this early stage any excess component and process may be existing. In the T set, the component is the spoon, the cup, the ear, and the salsa. We can choose this individual component by using 3 elimination questions. The answer of this question help determine to eliminate the component without loss of functionality of the product. There are 3 suspect questions to find suspect component and suspect process. First question is, should the component move or be able to move in relation to the preceding component in the assembly diagram? Second question, is there fundamental reason for the component being made of a different material which does not otherwise occur in the product? And the third question is, should the component be fitted or removed separately, because otherwise assembly or disassembly of other theoretical essential component would be impossible. Redesign. After the analysis phase, the suspect and the components are marked, redesign can be considered. For example, the ear is one of the suspect component. We can improve it by making the ear and the cup as a single piece of component. By this process, we can eliminate the suspect process and the suspect component. The last step of the DFMA process primarily involves the creation of the report. State of participant in the DFMA process, date and location which is held, key user requirement, outcome of the analysis, assembly diagram, alternative design, and evaluation. Okay, now we talk about what is machining. Machining is any various processes in which a piece of raw material is cut into a desired final shape and size by a controlled material removal process. Machining is a part of the manufacture of many metal products, but it can also be used on materials such as wood, plastic, ceramic, and composite. First, I will talk about the design feature to facilitate the drills. First, the drill should be always perpendicular to the drilling surface because it can avoid the starting problem and also help in ensuring the proper location of the hole. Second, avoid interrupted cut when straightness of hole is important. It is advised to use a guide bush at each re-entry surface. The center point of the drill must remain in the workpiece throughout the cut. Through holes are preferable than blind holes. It provides clearance to the tool and chip in the secondary operation like rimming, tapping, or honing, and if the drill bit always generates pointed holes, in blind holes as secondary operation are required. Recommended depth of the hole is maximum 3 times than the diameter of the hole. If it mere, it creates chip clearance problem and the possibility of deviation from straightness. Special tooling, equipment and technique are used for deep hole drilling. For example, gun barrel. It has deep as 5 times than the hole diameter. A minimum diameter about 3 mm is preferred for hole drilling as small diameter drills are more prone to breakage. It is required to dimension hole from the same surface to simplify fixturing. 6. Rectangular coordinate are more preferable than angular coordinate to designate the location of the hole. Design features to facilitate keyways. For generating external keyways, end milling cutter or slotting cutter has to be used and can be done much faster compared to other processes. To suit a cutting tool, blind axle keyway should be radius at the end. Width of keyway should be such that standard cutter can be used. If the end of the keyway is radiused in such a way that it could be cut by a slotting cutter, it will improve the speed of machining keyways. Milling and shaping is not recommended for internal keyways generation. For internal keyways, broaching machine should be used. Design features to facilitate milling cutter. We need to use standard cutter shapes and size. Specialized non-standard cutters are costly and difficult to maintain. Product design should permit the use of radii provided by the cutting tool. Allowing a bevel rather than a rounded corner for more economical machine. Next, use standard cutter to produce both side and ends of keyways in one operation. Avoid milling at parting lines, flash area and weldments for higher cutter life. Surfaces in the same plane or at least in the same direction in parallel planes are preferred. I think that is all from me for this video. So before I end this video, I want to recap. The first point is about what is DFMA and how the DFMA works. Next is about what is machining, and the last part of this video is about the design features to facilitate of drill, keyway and milling cutter. Thank you very much to our lecturers and all my friends who are helping me to complete this video. I hope this video will give some benefits to all of you who is watching this video. Bye bye.